When you solve a trigonometric equation in your calculator, the answer you get for theta can seem unexpected. Complete the following chart to learn how the calculator processes your attempt to solve for theta. When we try to solve for theta in an equation like cos theta equals -3/5, the calculator has to guess which quadrant the triangle is in. A calculator has a preferential order in which it tries to place a triangle. If it's possible to place a triangle in quadrant 1, the calculator will always choose this quadrant first. If quadrant 1 is not an option, the calculator will try to place a triangle in quadrant 4. If neither quadrant 1 nor quadrant 4 are options, the calculator will place a triangle in quadrant 2. The calculator will never place the triangle in quadrant 3. Now we'll complete the chart. If the angle theta could exist in either quadrant 1 or 2, the calculator always picks quadrant 1. If the angle theta could exist in either quadrant 1 or 3, the calculator always picks quadrant 1. If the angle theta could exist in either quadrant 1 or 4, the calculator always picks quadrant 1. If the angle theta could exist in either quadrant 2 or 3, the calculator always picks quadrant 2. Note that the calculator returns quadrant 2 angles as a standard position angle greater than 90 degrees. If the angle theta could exist in either quadrant 2 or 4, the calculator always picks quadrant 4. Note that the calculator returns quadrant 4 angles as a negative standard position angle. If the angle theta could exist in either quadrant 3 or 4, the calculator always picks quadrant 4. Now we'll move on to part B. Given the point P, -4, 3, Mark tries to find the reference angle using a sine ratio, Jordan tries to find it using a cosine ratio, and Dylan tries to find it using a tangent ratio. Why does each person get a different result from their calculator? Given the point P, -4, 3, we can construct a triangle in the second quadrant. Use the Pythagorean theorem to find the hypotenuse of the triangle, which is 5. Label all 3 sides of the triangle. We can now write the 3 trigonometric ratios. Sine theta equals 3/5, cos theta equals -4/5, and tan theta equals 3/4. Now we'll inspect Mark's calculation. Even though we know the triangle is in quadrant 2, since we have the picture, the calculator has no way of knowing the triangle is in quadrant 2. The calculator will find the angle using the chart we completed in part A. There is no further need for the triangle diagram above, since the calculator can't use it. Since sine theta is greater than 0, the angle could potentially exist in quadrants 1 or 2. When the calculator has to choose between quadrants 1 and 2, it always picks quadrant 1. Use the inverse sine feature of your calculator to get theta equals 36.87 degrees. Now we'll inspect Jordan's calculation. Since cos theta is less than 0, the angle could potentially exist in quadrants 2 or 3. When the calculator has to choose between quadrants 2 and 3, it always picks quadrant 2. Use the inverse cosine feature of your calculator to get theta equals 143.13 degrees. Note that the calculator returns quadrant 2 angles as a standard position angle greater than 90 degrees. Now we'll inspect Dylan's calculation. Since tan theta is less than 0, the angle could potentially exist in quadrants 2 or 4. When the calculator has to choose between quadrants 2 and 4, it always picks quadrant 4. Use the inverse tan feature of your calculator to get theta equals negative 36.87 degrees. Note that the calculator returns quadrant 4 angles as a negative standard position angle.